Dear colleagues, welcome back again. Now I would like to talk about in numbering system signed numbers or unsigned numbers. First of all, I have to mention three things. One is sign magnitude. The second one is ones complement. The third one is twos complement. So we must learn those three information. Let's start with sign magnitude. When we talk about any number, especially for the ones binary numbers 1 0 1 1 0 0 1 1, so it's a 8-bit number. When we calculate all those numbers 1 0 1 1 0 0 1 1, as you remember from the previous videos, the least significant bit is 2 to power 0. What is 2 to power 0? Is 1. And next to it 2 to power 1, which is 2. And next to it 2 to power 2, which is 4. 8, 16, 32, 64, 1, 2, 8. I believe you remember all those values, and then these are the position value of the bits, and as a result 1 times 28, 1 times 128, 128 plus 0 times 64 is 0. 1 times 32 is 32 plus 1 times 16 is 16 plus 0 times 8 is 0. 0 times 4 is 0. 1 times 2 is 2 plus 1 times 1 is 1. And as you remember, when you calculate this addition, 128, 160, 176, 78, 79, 179. So in other words, this binary number is equal to 179 as decimal number. Okay, so it is in normal calculation when we talk about unsigned information. When we talk about signed numbers, the the very most left digit is showing you the sign. It is like this. If it is 1, it is minus. If it is 0, it's plus. In other words, that 1 is showing that it's a negative number, 0 is showing that it's a positive number. A few examples: 1 0 1 1 0. Let's say this number, let's make it like 8 bytes because we are using 8 bits per character per numbers. So what is this? It is a negative number. What about this? 0 0 1 1 0 1 1 1. It is positive number. Okay, so how do I understand it's positive? Not because of here, not because of here, because of here. The first digit is negative. If it is 1, negative. If it is 0, it is positive. Let's come back to here. If it is like signed number, the first digit is going to be signed digit. Signed digit means you cannot multiply by 128. It is showing the sign. What does it do? It is showing minus value. Minus value of what? Minus value of all the other calculations. In other words, you cannot add 128, but 0 times 64, 0. 1 times 32 is 32. 1 times 16 is 16. 0 times 8 is 0. 0 times 4 is 0. 1 times 2 is here. 1 times 1 is 1. When you calculate the addition of all those numbers, 32, 48, 50, 55. So result is becoming 51. So 51. So this number, if we are using signed number, minus 51. As a result, here, if it is unsigned, we're talking about the above mentioned number 10110011 is equal to 179. If it is signed, is 10110011 is equal to minus 51. So for unsigned and signed numbers is calculated like this. Now when we talk about the second version of signed numbers, ones complement that we have to know. Ones complement means 10110011 can be converted by using ones complement. All ones becomes 0, all zeros becomes 1, 1. Okay, so then as you see, 1 becomes 0, 0 becomes 1. So when we talk about ones complement, so it is opposite of this number is becoming that number. Now if we calculate 2's complement, which is also easy. 2's complement is like this: 1's complement plus 1. Okay, now when we talk about this number 10110011 is becoming with 1's complement as 1's complement 01001100. So then plus 1 is becoming 01001101. So this is 2's complement of this number. Okay, why did we learn it? We are going to learn it. Why did we learn it? In the structure of CPU, while we are doing like arithmetic logic, we are using arithmetic and logic units. In computer knowledge, in computer literature, we don't have subtraction. We have only addition, because we are just having a loop and we are just increasing the numbers. We are just doing increment only. So in other words, here is the example: 46 plus 1 is equal to 47. Is it possible? Yes, it is possible. So because we are just increasing 1. Okay, 46 plus 5, so what is that? It's equal to 51. So what did we do here as a loop, logically, just to understand? 46, 1 increment, 47, 1 increment, 48. So it carries on like this. In a loop, 5 times later we achieve to 51. When we come back to here, 46 minus 36, for example, what is the result? So as I mentioned at the beginning, and not at the beginning, just now I mentioned, in computer, in hardware, we have only increment. So 46 plus something will be the result. So what's that? Plus something in a loop, plus something. What is something now? Minus 36. So in other words, 46 plus minus 36. So this is what we are going to do. So that's why we can represent 46 easily with binary numbers, but when we come to represent 36, we have to use 2's complement to represent minus 36. So again we are using the 8 bits. For 46 is going to be, let's make like this, as you remember, 8 bits: 128, 64, 32, 16, 8, 4, 2 and 1. So these are the position values for 46 we are talking about. Now how were we doing? So as you remember, from 46, do we get any 128? No, it's 0. Do we get any 64 from 46? No, it is 0. Do we get any 32? Yes. When we put 132, the remainder is going to be 14. Okay, 14. From 14, can we put any 16? No. From 14, can we put any 8? Yes. 1 8 we have put. When we put 1 8, remainder is 6. We have still 6 in our hand. After 8, 4. Do we have any 4 in 6? Yes, there is 1 4. So remainder is 2. In 2, do we have any 2? Yes, there is 1 2. Remainder is 0 in our hand. In 0, do we have any 1? No, it is 0. Now, the first step we put the values. The second step, is it plus 46 or minus 46? It is plus 46. That's why you can even see here it is plus 46, because of the first digit is 0. Okay, so now this is our number for 46, binary number. Now let us talk about, let me delete this part, let us talk about 36. When we talk about 36, first, do we have any 128 in 36? Of course not. Do we have 64? Not. Do we have 32? Yes, there is only 132 in 36. So when you just take out 132 from 36, remainder is 4. In 4, do we have any 16? No. Do we have any 8? No. Do we have any 4? Yes, 1 4. When you deduct 1 4, your remainder is 0. So in 0 you don't have any 2, you don't have any 1. So now we found 36 as well. Okay, now to make it to minus 36, what are we going to do? We are going to make 2's complement. 2's complement. So the new generation computers are architecture is done like this. 2's complement. What was 2's complement? What was 2's complement? First, all zeros will be 1, all ones will be 0. So 1's complement. In other words, so the result is 1 1 0 1 1 0 1 1. So this is when you convert this all zeros to 1, all ones to 0, so it is 1 complement. So from the previous video, maybe you can remember, we can add here 1. Okay, so now we are going to do addition. Okay, we are going to add here 1. Sorry, let me delete all the other unused place here. Okay, let's start. So let us remember, 1 plus 1 is 2. Can I put 2 here? No, because it's binary number, and from this 2 we are taking out one package of 2. When we take out one package of 2, remainder is going to be 0. This one is coming to end, coming to here to add. Sorry. Okay, So 1 plus 1 is 2. From this 2 we took out one package of 2, so this one comes here, this one package comes here, and the remainder is 0. 1 plus 1 at the moment is 2. 1 plus 1 is 2. So from this 2 we taking one package of 2, then we put 1 here, and then because we took out 2, so it is 0. Okay, 1 plus 0 is 1, and from now on 1 plus nothing 1, 1 plus nothing 1, 0 plus nothing 0, 1 plus nothing 1, and 1. Okay, so what is this? This is the 2's complement of minus 36. So in other words, so let me just copy here. In other words, minus 36 is equal to this number. So what can we see? What can we see now? You can pause the video and just check if you want to. So here is plus 36, here is minus 36. How do you know it's minus 36? Here it is. This number 1 is showing that it is minus. How it comes? It comes from 2's complement. How did we do? We just converted everything to 1's complement, plus 1 becomes 2's complement. Okay, now let's come back our duty. We said 46 minus 36. 46 minus 36. So in other words, 46 plus 36, because we cannot subtract anything from a number. So in other words, we are going to add this number plus this number. Okay, so now we are going to do like addition. Before we have done, I mean in the previous video we have done already. So this is 46 plus this is minus 36. Now we are going to add those two, we are going to add those two by using addition formula. Okay, let's see now. 0 plus 0 is 0. 1 plus 0 is 1. Okay, now let me put a space here. 1 plus 1 is 2. You cannot write 2 here because 2 is your base. So from 2 we are just taking one package, and this package is coming here. So then as a result we have 0 here. Okay, so now we are here. 1 plus 1 plus 1 is 3. From this 3 we are taking one package here. So after that remainder is 1, because from 3 we took one package, put it in the on the right hand side, and then result is 1. From 3 we took out 1, 2. 1 plus 1 is 2. You cannot write put 2 here. 0, this one package comes back here. 1 plus 1 is 2. We put 0 here, and one package comes here. 1 plus 1 is 2. We put 0 here. This one package comes here. 1 plus 1 is 2. We put 0 here, and this one package comes here. Okay, anyway, so this one is coming here. Okay, so this 2 addition has been done. 46 plus minus 36 is this number. But what was our number of bits? 8. So let us count 1, 2, 3, 4, 5, 6, 7, 8. So I don't take the rest, only I take the 8 bits. So as you see, 0, 0, 0, 0, 1, 0, 1, 0. This is the result. 0 0 0 0 1 0 1 0. What is this? Is equal to 128 64 32 16 8 4 2 1. Let us see. This is okay. This is okay. This is okay. This is okay. Now result 0 plus 0 plus 0 plus 0 plus 1 time 8 8. 1 time 2 is 2. 8 plus 2 is 10. Oh, result is 10. Let's come back here. 46 minus 36 is equal to 10. Okay, is normal life, is real life, and it is correct. 46 minus 36 is equal to 10. Is normal, and we have shown how to make it. So maybe this part is a little bit confusing. So because we are using like 8 bits, we are playing with the 8 bits. So this one is outside of our 8 bits. Think about some kind of like mechanical numerator. Let's say there are 3 digits for the numerator. What is the highest number for the 3 digits? 999. So when you just make 998, turn 1 becomes 999. When you turn one more time, because it has 3 digits, you don't have the fourth one. Normally it becomes 1000, 1000, 1000, but that one disappears because there is no 4 digit there. So think something like this. So when you just increase, when you just add those two, you take only 8-bit part and this one disappeared. Result 10. So as you see in the real life, 46 minus 48 is equal to 10, but in computer 46 binary version is like this, 36 binary version is like this. Minus 36 is 2's complement of this binary number. All zeros becomes 1, all ones becomes 0, 1 complement. Plus 1 is 2 complement. So when you add this 46 plus 2's complement of the 36, which is minus 36, result is going to be 10. Okay, thank you very much listening for today's course and for this video. I hope to see you soon in the next part.